Inside the world of modern agriculture, there is one industry most people never imagine exists: an industrial-scale system dedicated entirely to soft-shell turtles. In the United States, these animals are usually associated with swamps, slow rivers, and the quiet rhythm of wild wetlands. But across large indoor farming complexes in other parts of the world, soft-shell turtles are raised with the same precision found in high-tech fish hatcheries and intensive poultry operations. Every year, millions of turtles move through a structured pipeline: selective breeding, temperature, controlled incubation, indoor nursing, grow-out ponds, and finally, fully mechanized processing inside specialized plants. What was once a wild, unpredictable creature has become a standardized agricultural product shaped by engineering, data tracking, and strict environmental control. Breeding turtles carry digital IDs, water systems run on automated sensors, and incubation rooms adjust temperature with accuracy down to a single degree Fahrenheit. This level of control determines not only survival rates, but even the gender ratio and growth performance of each generation. For the farm owners, every egg, every hatchling, and every pound of weight gain is part of a carefully calculated business model. Today, we'll step inside this hidden industry and follow the complete journey of a soft-shelled turtle, from the moment a breeding adult is chosen, to the high-tech incubation chambers, to years of controlled growth, and ultimately to the processing lines where the final products are prepared for the market. Before we move deeper into this journey, let me ask you something. Based on what you've heard so far, do you think industrial turtle farming is a brilliant innovation or a controversial practice? Comment 1 if you consider it progress, or 0 if you think it raises serious concerns. And don't forget to subscribe to the channel so you don't miss any of our in-depth articles on the hidden systems behind modern agriculture. The journey begins long before a single egg is laid. Inside large soft-shell turtle farms, only a small percentage of adults are selected to become breeders, and the screening process is far more rigorous than most people expect. Each turtle is evaluated for body weight, shell integrity, limb strength, growth history, and overall health. Individuals with deformities, slow development, or inconsistent feeding responses are removed from the breeding program. Those that pass the evaluation receive a digital ID tag or microchip. From that moment on, every detail of their life is recorded: feeding patterns, reproductive cycles, growth rate, and even behavioral traits. This data allows farm managers to track lineage and pair turtles strategically to produce stronger, more productive offspring. Over time, entire bloodlines are shaped to fit the needs of industrial-scale farming. Once selected, the breeders are transferred to semi-natural reproduction ponds, shallow systems designed to mimic the warm, sandy environments where soft-shell turtles naturally spawn. Even the lighting follows a controlled day-night cycle to align with the turtles' internal rhythms and reduce stress. Diet during this period becomes especially important. Breeding adults receive a protein-rich mix of minced fish, freshwater snails, chicken liver, and fortified supplements containing calcium and trace minerals. This nutrition plan helps females develop thick-shelled, nutrient-dense eggs with a high chance of survival. Farmers monitor feeding closely, adjusting the formula as the breeding season approaches and as individual turtles respond differently to the diet. Every detail in this stage serves one purpose: producing eggs that can withstand both environmental stress and the mechanical handling required in large-scale farming. A healthy egg is not just the beginning of a new life, it's also the foundation of the entire production cycle. In a system where tens of thousands of turtles may be raised at once, the quality of each clutch determines the efficiency of everything that follows and decides whether the farm truly makes a profit or falls behind. Once the breeding females finish laying, the timing on the farm becomes very strict. Soft-shelled turtles follow their natural pattern: climb onto the sandbank, dig a nest with their hind legs, lay a cluster of eggs, cover everything, and quietly return to the water. In the wild, the eggs might stay hidden for weeks. In an industrial system, they stay buried only long enough for the sand to settle. Workers then move in with shallow trays and small tools, brushing away the top layer of sand until the white shells appear. The nest is opened slowly so the walls don't collapse and crush the clutch. Each egg is lifted by hand and checked for cracks, deformities, or stains that suggest infection. Any suspicious egg is removed on the spot. On a large farm, thousands of eggs can be collected and screened this way in a single shift. From there, the trays go straight into the incubation room, a sealed, climate-controlled space that replaces weather with numbers on screens. Temperature and humidity are kept within narrow limits, because one unusual trait of turtles becomes very useful here. The sex of the hatchlings is determined by temperature, not by chromosomes. Just a small change in heat can push a batch toward mostly males or mostly females, so the room is divided into zones, each set to slightly different targets depending on the farm's long-term plan. The eggs are set into disinfected sand or artificial incubation media and stacked on metal racks. A central panel shows live data and triggers alarms if anything drifts outside the safe range. Staff track hatch rates for every batch and link them to specific parent pairs. Over time, this creates a practical map of which bloodlines produce strong, uniform hatchlings under these controlled conditions. With all of this in place, the incubation period shrinks dramatically. Instead of waiting 60 to 90 days like in the wild, farms often see hatching in about 30 to 40 days. Then, almost at once, quiet trays turn into rows of tiny, moving bodies as the hatchlings break through their shells. At that moment, the focus of the operation shifts. Fragile eggs are no longer the priority now. The challenge is raising thousands of young turtles toward market weight as efficiently and consistently as possible. Once the hatchlings emerge, they enter the most demanding and expensive stage of the operation, growing thousands of tiny turtles into market-size animals. In the first weeks, they are kept in indoor nursery tanks with soft bottoms and gently circulating filtered water. Temperature, oxygen, and pH are checked constantly because even small swings can trigger disease outbreaks or sudden mortality. Here, the young turtles learn to feed on their first formulated diets, fine pellets blended with ground fish, vitamins, and minerals for fast shell and muscle development. Filtration runs around the clock, and basic water tests are done several times a day to make sure waste doesn't build up faster than the system can handle. After a few months, when the turtles are stronger, they move to the grow-out area of the farm. These are larger outdoor or semi-indoor ponds built for control and efficiency. They are shallow, easy to drain, and laid out so workers can reach any corner quickly. Aerators keep oxygen levels stable, and fresh water is added or exchanged regularly to dilute ammonia and harmful bacteria. Feeding in this phase follows a strict schedule. Juvenile turtles receive nutrient-dense pellets, chopped fish, and sometimes aquatic plants like duckweed or water spinach. As they grow, pellet size and protein levels increase to support rapid weight gain. Depending on the season and water temperature, they may be fed 2 to 4 times per day, since warmer water speeds up digestion and colder water slows it down. Periodically, staff sample and weigh a group of turtles from each pond to check growth curves and adjust feed amounts. This cycle continues for 4 to 5 years, much longer than for chickens or fish, but necessary for soft-shell turtles to reach a typical market weight of 3 to 6 kilograms. Throughout the grow-out period, the farm logs survival rates, feed conversion, and health issues for each pond. By the end, the goal is a uniform population of heavy, healthy turtles, animals that have gone from fragile hatchlings in nursery tanks to robust livestock ready for the final step of their industrial journey: harvest and processing inside the plant. After 4 to 5 years in the grow-out ponds, the turtles finally reach market size and the farm shifts into harvest mode. Work starts early in the morning when the water is cool and the animals are calmer. Workers move through the ponds with nets, guiding turtles towards shallow zones and lifting them by hand or with scoops. Each turtle is rinsed to remove mud, then placed into clean holding tanks to stabilize before processing. Animals between 3 and 6 kilograms with strong movement and unmarked shells are labeled as premium, while others go to different product lines or more price-sensitive markets. Uniform size matters because buyers expect consistent portions and the plant's machinery is calibrated around specific weight ranges. From the ponds, the turtles are moved to the processing building. They enter a washing area where high-pressure water removes remaining dirt from skin and shell. Strict hygiene rules apply here. Equipment is sanitized regularly, and the plant is divided into dirty and clean zones, so bacteria from live animals doesn't reach finished products. Then trained workers remove shell and skin, combining manual knife work with tools shaped for the flat, flexible body of a soft-shell turtle. Internal organs are inspected and separated. Some parts are discarded under food safety rules, while others may be saved for specific culinary uses. The meat is trimmed, washed, and divided into standard formats. Some customers buy whole-dressed turtles, others prefer cut sections, fillets, or frozen blocks ready for restaurants and processors. Each unit moves along a conveyor into the packing area, where it is vacuum sealed, rapidly chilled or frozen, and labeled with production dates and batch numbers. By the time the boxes are stacked in cold storage, the transformation is complete. Animals that spent years growing slowly in managed ponds have become standardized, traceable products ready to move through refrigerated trucks and global supply chains to their final destination on the plate. The final product leaving the processing plant marks the end of a long, engineered journey, but it also raises questions that follow the industry wherever it grows. Soft-shell turtle farming exists partly because wild populations reproduce slowly and face pressure from habitat loss. By raising turtles in controlled environments, farms help reduce harvesting from the wild. Yet the system is not without challenges. Soft-shell turtles live a long time and process food slowly, which means they can accumulate heavy metals or bacteria if water quality and feed aren't managed carefully. Modern farms use filtration systems, regular water testing, and controlled diets to limit these risks. But even small lapses can affect safety. As the industry expands, consumers and regulators increasingly demand clearer standards to ensure these animals are raised responsibly. Soft-shell turtle farming sits at the center of that tension. It blends biology, engineering, and economics, using data and technology to raise an animal that was once available only through wild harvest. Whether the industry grows or remains limited will depend on how well it balances efficiency with transparency and environmental responsibility. In the end, every processed turtle carries the weight of these choices, from how the breeders were selected to how the ponds were managed. The future of the industry will hinge on whether it can maintain both productivity and public trust while shaping the next generation of farm turtles.